Anything I can help you with before we get started?
I'm good.
Okay. Do you have the notes typed out or looked at
Yes.
so that you have a copy of what I'm going through? Okay, so I'm going to go ahead and share my screen with our notes for today for our Zoom lecture. So today starts our lecture called Trigonometric form of complex numbers. Unlike real numbers, complex numbers cannot be ordered. Now, before I go on any further, do you guys know what a complex number is? Okay. I'm going to say, yeah, you do, but a complex number is a number that usually can be written as a plus bi. It could be a real number, it could be part imaginary, it could be, but a plus bi is what we call a complex number. So unlike real numbers, complex numbers cannot be ordered. For example, in the real numbers, you can say, hey, I've got 1, 2, 3, 4, I've got -1, -2, -3, and I can order those numbers. Well, complex numbers cannot be ordered. I can't say 3 plus 2i is larger than 3 plus 1i. So I just don't order the complex numbers. But one way to organize them and to illustrate them is by using a graph. To graph a complex number, like I want to graph 2 minus 3i, our familiar coordinate system, the xy plane, must be modified. We do this by calling the horizontal axis, instead of calling it the x-axis, we're going to call it the real axis, and instead of calling the vertical axis the y-axis, we're going to call it the imaginary axis. Then, even though we can't order the complex numbers, at least we can graph them in what is called the complex plane. So if I ask you to graph the complex number 2 minus 3i at the right, well, one of the first things you have to do, because this looks like an xy plane, one of the first things you have to do over here is say, this is my real axis, and up here, this is my imaginary axis. Let's see if that. And in looking at how I want to graph 2 minus 3i, I'm saying, well, 2 is the real part of this complex number. So I'm going to go 2 spaces. Let me take my point. I'm going to try to take my point. Okay, grab it. I'm going to go 2 spaces to the real part. And then in order to incorporate the -3i, I don't really do the I just do the negative because the I is already up here is my y-axis. I just basically move this down. I move it down to 3 spaces. Now, that point right there is not the complex number. It's a point, but it's not a complex number. And what I have to do for graphing the complex number is I actually have to go like this. I have to take a ray and go from the, because otherwise that would just be too much like just graphing an x in the xy plane. What I have to do is I have to go ahead and draw an arrow to that point. And now I have graphed the number in the complex plane. The number itself being that point, but the arrow representing something very specific. So I'm in the imaginary world here, or I'm in the complex plane rather. Each non-zero complex number graphed in this way becomes a unique, what we call directed line segment. It goes in a certain direction. And the directed line segment that I just drew, it's not really a line segment, but it's because it's got that arrow on it, it's directed. It's called a vector. Maybe you've heard of vectors before. Maybe you haven't, but a vector has got magnitude and direction. So in this case, it tells me if I want to go and get to that complex number, I go 2 to the right, I go 3 down, and then this is my complex number, also known as a vector. If I want to graphically add 2 complex numbers together, well, you guys know how to add complex numbers together because you've done that in previous math courses, but I want to show you what it looks like graphically. So if I asked you to add 4 plus I and 1 plus 3i, you would go ahead and just add those like terms. So you have, actually, let me go ahead and do this first. I'm going to zoom into about 150% for those of you who are on a small window. Okay, there we go. So if I want you to add two numbers together, like 4 plus I and 1 plus 3i, you would just say, okay, 4 and 1 add up to 5. That's no big deal. And then for your imaginary parts, you would say 1i plus 3i happens to be 4i, but I should put a plus on there, okay? So you add them just because you add like terms and you don't think much about it. But what I want to do is I want to talk about graphing these numbers in this X real and Y imaginary state. So where would I go? Let me grab a point. Where would I go to plot the point 4 plus 1i? I would go 4 along the real axis, and then I would go up 1. Let me see if I can get that in the right place. Move up 1. There you go. And that would be my first point, 4 plus I. Correct? I didn't hear you, correct?
Yes.
No, that's not correct. You don't just plot a point. What you do is you use a
Array.
array, an arrow representing the number in the complex plane, which is not just a point, it is a vector here. And it has magnitude and it has direction. So what I have to make sure that you do, and this is not on your quiz today, okay? This will be on like quiz next week, but this is not on your quiz next week, or this week, but it's still good to use proper notation at all times. If I want to go ahead and graph 1 plus 3i, grab another point. So I'm going to go on the x-axis, on the real axis 1, and I'm going to go up 3. Right there, did I do it up 3? There we go. And again, have I correctly located 1 plus 3i? Not yet. Let me go grab another arrow, okay. Change my arrow.
So the rays stop at the point?
Yes, they do. So that's why I've actually got those. Yes, the rays stop. In fact, yes, they do. If I want to try and graph 5 plus 4i, which is my answer for this sum, I'm going to grab my point. I'm going to go on the x-axis 5. The real axis, so x-axis 5, real axis 5, and then up 4 spaces to my sum. And I'm going to say that might be, okay, that's located pretty well. What I'm going to do is I'm going to grab a red arrow now, because the red arrow is actually going to represent that I actually added them together. I started with 4 plus 1i and I added 1 plus 3i together. For those of you who are taking a physics course or will be taking, good luck if you're taking a physics course online, okay, but you'll be taking a physics course soon. You'll be working with vectors quite a bit. And so in this course, we give you an introduction to those vectors. Well, I'd like to let you know that the sum can be represented by the vector, which is going to end up being the answer is going to be the diagonal of a parallelogram. So what I'm going to do now is I'm going to take I'm going to try to make a parallelogram here. If I were to connect the endpoint of the first vector, I'm sorry, that's my second vector, with the endpoints of my first vector, which one was first? Yeah, this was the first vector. You can see that the resultant happens to be the diagonal, the result or the the sum right here, the final answer is the diagonal of the parallelogram. Does anybody know how this is used in physics? Shout out to anybody.
Or calculating distance and speed and things like that.
Yes, but specifically what it represents is, let's say that you've got a rock right here at the origin and you want to move this rock, but you're not strong enough to move the rock. So you put a rope on one side of the rock and you've got somebody up here pulling in this direction. And then you've got somebody pulling in this direction on the other end of the rope. And what that does is that moves this rock, but in what direction it moves it, well, it depends on how long your forces are. Perhaps you're stronger and you can pull better than somebody else who's over here. And then so what happens is this red vector is a result of where the rock would move to. So yes, but there's lots of great applications of vectors. So we're just going to give you in this section, I think we're in chapter 9, we're asked to introduce this to you by the physics department so that when you get to those physics courses, you go, oh yeah, I've seen that in math. I didn't do much with it in math, but I called them imaginary. But then we use the angles here, and we use the magnitude of this vector, and we use the angle of this one to calculate the diagonal of the parallelogram. We don't get into the physics part of this in this course, but again, we're just going to introduce you to some of the basics. Okay, here's another example. Basically, I think you could do this on your own, but I'm asking you to find the sum of 6 minus 2i and negative 4 minus 3i. So I've got it written over here, and I like to add these in, I don't know, vertical format. I think maybe I blame it on my 3rd grade math teacher who said, hey, if we add things up, you line them up in, in their correct unit. So I always go over here. Some people can add sideways, like horizontal like this, but I'm not one of those. So over here, I wrote 6 minus 2i, and I've got negative 4 minus 3i, and I say, hey, can you guys just add my like terms together? And you all say the answer would be 6 minus 4, 2, negative 2i, and a negative 3i.
Negative 5i.
Negative 5i, yes. So what I want you to understand is, not are we just going to be, because some of you guys actually did that in your last math course, maybe it was math 64, math 126, depending what course you took here, you go, hey, I could add some imaginary numbers together. But what we want to do is we want to give you a context of what this is and what I need to do. I need to go up here and I need to copy this. So what I want to do is I want you to be able to graph these in the real and in the imaginary. I want you to graph them what's called the complex plane. So again, this is going to be the real. I should start that, and that's the very first thing I should label. Did you ever have a math instructor who said you have to label the x-axis, you have to label the y-axis, the y-axis? No, I didn't, and I don't require it, but it's not good. You should know which one is it. I think I spelled imaginary wrong. Something looks wrong with it. Imaginary. Now, this might look a little wonky because I go, gee, I didn't go very high on the y-axis, but I was running out of space, and then I looked at these numbers. Okay, so let's consider the very first number, 6 minus 2i. 6 is what's considered the real part, and negative 2 is considered the imaginary part. So I'm going to take a point. I'm going to go x is positive 6 on the real axis. There I am, close to it. That's not where I'm supposed to be. I need to also move that down 2 spaces. So I'm going to try to move that down 2. Oh no, not the x and y-axis. Let's grab the point. There we go. And let's move you. Okay. Let's have some difficulty here. Okay. Let's grab this point and move it down sort of where negative 2 is. Is everybody happy with what I have just graphed? Say no.
No.
Because what you must do is you must not just plot a point and say, hey, I can graph this. it looks like it's in the XY plane if you do that, even though you have this marked. So I actually need you to try to draw the vector going from the origin to, there we go, to that point. Now we're going to graph the second number, which is -4 minus 3i. Well, -4 means I need to take the point on the real axis to -4, which is here. And then I'm going to go down 3 spaces. So let me see if that's it. I think that's pretty good. Oh, wait a minute. It's not good enough until I draw the vector itself, which represents that complex, the length and the direction. The length called the magnitude and the direction of that. Okay, it'd be really nice if I got those to connect the origin. Okay. Let me go ahead and save this before I lose something. All right. The answer that we got, which was 2 minus 5i, can be located in the real axis 2, go down 5, not a problem. And that resultant I'm going to go and show as a red vector. So if you have colored pencils at home, all my colored pencils are at school, believe it or not. Haven't been over there since school let out on the Wednesday we had before spring break. Okay, so that's the resultant of the 2 vectors. If I go ahead and copy this vector, copy that. Technically, what's happening is if I, or actually I won't do that one yet, okay. Let me copy this one. If I started with 6 minus 2i, and then I put a vector, and then I put a magnitude and direction. Oh no, don't move that. From there, what I end up getting, and this is how they would probably do it in physics, they would say, hey, from there you've got this vector going to, and so this is your result. But what we like to do mathematically is show you that the resultant is actually found by using the diagonal of what's called a parallelogram. Okay? So we'll get on to some easier stuff. Oh no, I think that's about all the easy stuff we'll do. The figure at the right shows a complex number x plus yi. Oh, remember how I do this. This is called the real x. This is called the imaginary. I already have that labeled for you. I've got x plus yi. I've gone in the x direction and then I've gone in the y direction and I've located my point P. The vector OP corresponds to that complex number. What I'm now going to do is give it a direction angle, which I've called theta. So you can see that my ray, or my vector, I'm going to call it a vector instead of a ray. To me, it's a ray, but to physicists, it's a vector. From O to P, my vector, O to P, has a magnitude of what we're going to call R. And this is going to go back to everything we've learned about trig and your Pythagorean theorem. The following relationships among R, theta, and X R, theta, X, and Y can be verified by looking at this picture. Did you know that R, okay, I'm going to say X is R cosine theta. I think you've seen that before. The cosine of theta is X over R. So what I'm going to say is by multiplying, by kind of cross multiplying, I'm going to get X is equal to R cosine theta, which is exactly what we did when we were working on polar form. I have Y is equal to R sine theta from polar form or from trig form, y over R, I just multiply both sides by Y. And what is R equal to? Well, let me reveal what R is equal to. R is equal to what? The square root of X squared plus Y squared. The tangent is still Y over X. The tangent of your angle theta is still Y over X, but I have to make sure that X cannot be 0 because you can't divide by 0. And besides, you don't really want to go in a no direction this way, okay? That means you just basically you're just staying at the origin and just moving around. So we're not going to go ahead and let x be 0. For the same thing, and this is on your quiz for Friday, or that's I'm going to release today, but you're going to have to use some of these same relationships on your quiz as we are doing now. So this is like, even though not being quizzed on it, it's a good helpful review. If I give you x is equal to r cosine theta and y is equal to r sine theta from relationships given above, how can I write x plus yi in another form? What we do is we call x plus yi standard form, standard rectangular form. And what I want to do is I want to change it into polar form. So how do I do that? Let me do the reveal. Well, what am I going to let x be? X is going to be just what it was before in polar, just was like it was on trig. S is going to be r cosine theta. What's y going to be? Yes, you guessed it. It's going to be r sine theta. There's only one little difference here. I have to make sure I include an I at the very end. So it kind of looks like a plus bi form. I need to warn you that I is not inside the angle. It's just written at the end, just like it is here. You say, okay, that doesn't look so hard. Well, here's what we're going to do next. Since both of these have a factor of an r, let me do the big reveal. I'm going to factor an r and put the r out in front. Then I'm going to have r cosine theta being left in the parentheses or in a bracket. And I'm going to have the I sine theta, and I write the I in the front here just because I want to make sure you don't goof that up with the angle. And so this is called R's out in front. We've got cosine of theta and I sine theta, where I was at the end here in our imaginary form. We're going to write it here in front of the trig value on the sign. Now, I have a very special notation that I use for this. There's an R, there's a cosine theta, and there's I sine theta. This is the same angle that that is, theta, theta, theta. And I get so tired, and I didn't realize how tired I got until I was typing up these notes. I'm going, I am so tired of writing cosine theta plus I sine theta. Well, I've always shortened that. And let me show you how I've shortened that so you don't get confused. I always shorten that. Comey likes to call this R cis theta. Where did I get the cis from? I got the cis from the fact that I'm too lazy to write out cosine theta. So my C stands for cosine theta. My I stands for the I that's supposed to be in front of the sine of theta, and the S stands for sine of theta. So when I see R cis theta, I go R cosine theta plus I sine theta. And again, it's just shortcut notation. I have to write this out every single time. Most of the time I will write this out for you, but every once in a while you'll see in the notes I just go to cis theta and I just go, come on guys, I'm just so tired of typing it that you can go ahead and use my shortcut notation, which is just not my shortcut notation. Other people use it too. Okay, the expression, this expression, which expression are you talking about? This expression, this one right here. Okay, let me not do that. I shouldn't remove that arrow because you might go, what happened to that one? Okay, so this is called rectangular form from the rectangular coordinate system that had x's and y's in it. This is our old imaginary number, and this is now our trig form, otherwise known as polar form of the complex number x plus yi. The number r, right, the number in front, r, which is the hypotenuse of that lovely right triangle, is called the modulus, or I just lost my thought. What else is it called? Oh, I know. Okay. Or it's called the absolute value of x plus yi. We don't use that very often, but they do use that in physics, so I do need to point that out. Sometimes r is called the absolute value of x plus yi. Remember that r represents the length of the vector. They also call this the magnitude. The vector, I'm sorry, the angle theta is called the argument. And I don't like to use the word argument. I just usually call it, it's the angle theta. And I also need to let you know, angles coterminal with such angles are also possible. So you have to remember about how to get there in the trig plane. I can go into quadrant 1 by using a positive angle. I can go into quadrant 1 by using a negative angle. So these particular angles, the theta, are not unique. Again, I think you understand that if I go up my angle theta, that's how I like to have it in standard position. But I could also, for this vector, I could also go ahead and go around this way. And then my angle theta would be in a different direction. But most of the time, we really like theta to be in standard position. So one of the first things you have to do on your homework that's going to be due next Monday is express 2 cosine 300 degrees plus I sine 300 degrees in standard rectangular form, which is x plus yi. So you go, okay, I don't know what to do. Oh no, it's so easy because you've got in your mathematical soul, you know the cosine of, let me see, cosine of 300 degrees. You know what angle that's in. I mean, you know what quadrant that's in. You know what its value is. You even know whether it's positive or negative. So the 2 is going to remain in front. The cosine of 300 degrees is positive 1/2. The I needs to be in there. And then the sine of 300 degrees, which is negative radical 3/2. That's called going from polar form or trig form into rectangular form. Now I do have to clean this up. I'm going to multiply the 2 times the 1/2. I'm going to multiply the 2 times this fraction right here, so that actually I might choose cancel. So in revealing my final answer is going to be, reveal this. My final answer is going to be 2 times 1/2, which is 1, and radical 3, the negative sign, the 2's cancel, and negative radical 3i. What I have right here is I want to show you what this answer looks like in polar form. And that's why I have this graph here. It doesn't ask me, oh yeah, it does ask me to graph it. There's this graph. Okay, graph, I see it. Ooh, graph. Let me highlight that. I do want that graphed. Okay. So now in graphing, what I need to do is say, okay, I'm going to go on the real axis, on the x-axis. I should call this the real axis though, huh? Let me add text to this. I'm going to call you the real axis. I can't see the word real. Where are you, real? Don't wanna. There you go. So I'm going to call this the real axis. I'm going to call this the imaginary axis. I really should have done that earlier, but I didn't. And I spelled imaginary wrong again. This is my imaginary axis. Let me do one more thing to make sure everything is nice and pretty. I'm going to take the color away from that line, and I'm going to make this transparent so you can actually see better. Okay. So I've got the imaginary part, I've got the real part. Well, if I want to graph this in polar form in my x, and my real and imaginary, my complex plane, I need to take my point, which is on the real axis 1. So I'm going to go to 1. I'm going to go down about radical 3, which is what I have gotten from my calculator to be almost 2, about 1.75. It looks like it's more like 1.5. Okay, so I'm going to go like to 1.75. I'm going to say, okay, I want to graph that. Did I do a good job graphing that point in the complex plane? No, because I didn't draw my vector. So I'm going to draw my vector. I'll shorten my vector. I'll try to shorten my vector. Now I have graphed that number in the complex plane. But just to show you that where I started with is what I have, that looks pretty much like it's a 300-degree angle right there. A 300-degree angle. My R, the length of my vector, happens to be 2. The length of my vector is 2. Now we're going to be using this information, I think, in a little bit. So try to keep in mind that 2 cosine 300 degrees plus I sine 300 degrees is this complex number. Example 3. It says express square root of 3 is in front, cosine 2 pi over 3 plus I sine 2 pi over 3 in standard form. And standard form is x plus yi. So all you do is you just multiply it all out. Oh, and then it says graph 2. Okay, so I've got radical 3. The cosine of 2 pi over 3, I hope you know the cosine of 120 degrees is -1/2. Yes. The sine of 120 degrees is positive radical 3 over 2. When I multiply these two together, I'm going to get a negative number, but nothing cancels like it did in my very first answer. So I'm going to get, for my real part here, I'm going to get negative radical 3 over 2. For my imaginary part, my radicals actually disappear because the square root of 3 is just 3. I still have my I. I've written my I at the end. I write my I at the end because I do A plus BI form. I do not write I at the end when I've got my polar form because I like the cis theta, I like the cosine I sine theta, which is what's standard in all your math and your physics. Okay, in looking at how I have to graph this, because you know I have to graph because it says graph. So make sure when you are looking at your homework that you do all that practice graphing. I'm not saying it's difficult, but make sure that you do it. What we have to do is we have approximation for radical 3 over 2. Now on your quiz today, I'm going to give you the approximate radical 3 over 2 for polar form, so you don't have to worry about that. Radical 3 over 2 is, when I put it in my calculator, and I lost a negative sign here. Do you see how I lost a negative sign? Okay, I need to add a negative sign in here. That's a negative on here, and I don't have a negative. So what I have to do is I'm going to save this so I don't lose it. I'm going to go back into my math type, which I don't think you can see when I do this, my equation object, and I'm going to put a negative sign in front of that. Sorry for that. Losing a negative sign, first time today. Okay. And then I've got 3 over 2 for my imaginary part. Let me go ahead and copy this. I'm graphing. Yes, if you were in class and you did not label this, I would be taking half a point off for that, and I would be taking half a point off for you not labeling the real part. But maybe in these times of COVID, I wouldn't do that. Who knows? Okay. No, real, you're too small. Okay. So there's my real axis. Say that. Maybe. Okay, so what I have to do, since this is negative radical 3 over 2, I don't know exactly what it is, but it's very close to -1. What I'm going to do is I'm going to grab this red point up here, and I'm going to take it down on the x-axis, I'm sorry, on the real axis, to about -1, which is, I'm going to say, somewhere there. And then I have to go up 1.5. I don't have much of a graph here. I have to go up 1.5 in the imaginary direction. I think that's too high. Let me see. I think that's too high. Okay, that's looking pretty good. Have I successfully graphed this complex number? No, not until I put in my, what mathematicians call array, but what physicists call a vector. So the length of my vector is actually radical 3, because that's my R. My angle is 120 degrees, and that angle theta is in standard position. Let me go ahead and kind of draw that in. There's my angle of about 120 degrees. So this represents the length of my vector. This represents the angle, and this represents my graph of my x, or this represents my complex number, and then this represents my graph of that complex number. Whew. It took me a long time to make these notes look like this, and I'm glad it's actually working, okay? Because you never know when you're going through this. Okay, so what are the steps going to be? For those of you who need steps, you can write these steps down on your homework, because you're allowed to use your homework on your quizzes, so you can write these steps down if you want, or just get it in your mathematical soul. First of all, sketch a graph of a number in the complex plane. Well, what are we doing? Now we're going backwards. We're going to convert from standard to trig form. So this is a little bit different than what we just did. What I'm going to do is I'm going to start with this and try to go back to polar form. So somebody's puppy. My puppy's not barking today. Okay, not yet. Sketch the graph of the number in the complex plane. So why? Because you want to know where it's kind of located. Find r. How are you going to find r? By using x squared plus y squared equals r squared, by taking the square root of x squared plus y squared. And how are you going to use and figure out the angle theta? Because I got to know what this angle is. It's easy for me to graph this, but how do I know what the angle is? I'm going to use the tangent of my angle as my y over my x, and x can't be 0. Now I have to tell you that number 1 is the most important step, because most students goof up the errors because they don't have it in the right quadrant. Remember that your angle theta can be many different values and different ways to get there, and I got to make sure that you know how to sketch a graph of the number in the complex plane and what quadrant it ends up in. How come I lost it? What happened to that? Let me go back. I don't like the fact that I lost that. Oh, there it is. Okay. Okay. Save this because I don't want to lose it when I reveal that. So you go, Cummy, this doesn't look so hard. It's not that hard. If I give you radical 3 plus I, and this is an x plus yi form, and I ask you to take this, which is an x plus yi form, and write it in trig form,
Hey.
Then you have to graph it. Also, I've got this next one, example 5, express 5 minus 5i, which is in complex a plus bi form, but we want to put it in trig form. Trig form means what? Trig form means I want to have this. I want to have cis theta. I want to have r cis theta. I want to have r, I want cosine of my angle. I want I sine of my angle. This is called polar form. This is called standard complex form x plus yi. This is what I need now from what you had to begin with. So I don't have any work down here. Okay, example 6. Find the product of two complex numbers, and example 7. So this is what you have in your notes, but I hope that I have on my next page example 4 done. Yes, I do. Okay. I've got example 4, I've got example 5. Okay. It says express, what is this? Oh, that's x. Okay. Express x plus, what's this? That's my yi. So let me go ahead and write that. Oh, I can't write that up there. Let me try to write that up there. X plus yi. Okay. Not capital X, Microsoft Word. We don't need to use capital letters on our variables. So this is x plus yi. This is x plus yi, but I want x plus yi changed into trig form. So here, and then of course we're going to graph it. So here we go. Number 1. Did you know that x was the negative radical 3 and y was 1? Of course. Next, the reveal. One of the first things I do is to take x squared plus y squared and set it equal to r squared. X squared plus y squared, well, taking a negative radical 3 and squaring it Taking a 1 and squaring it gives me 3 plus 1. 3 plus 1 is 4. I took the square of both sides. I did not put a plus or minus sign because r is the length of my vector and r is the radius of my triangle. I never have r being negative. So I've got r is equal to 2. Okay, now what am I trying to do? Put it in trig form. What does trig form look like? Trig form looks like r cis, let me go find a theta. R cis theta, where are you, theta? There it is. That's what this means. Put it in trig form. I need my r. Well, guess what? I got my r. All I now need to do is find my angle theta, and we're done. We're good to go. So here's my next reveal. To find my angle theta, I'm going to use the tangent function. The tangent is the y over the x. The tangent is the y, which is 1 over the x, which is, thank you for your help, negative radical 3. I'm going to rationalize that, and then I got to solve. The tangent of 30 degrees has got a lot of 3's. The tangent of 30 degrees is radical 3 over 3. But I've got a negative in there. So I know that my tangent is negative in quadrant 2, and I know it's in quadrant 4. Which quadrant do I want to be in? That's the big question. Do I want the angle of 5 pi over 6, which is the same as 5 times 30 degrees? Do I want 150 degrees, or do I want 330 degrees? Do I want 11 pi over 6? Because 5 pi over 6 is 5 times 30 degrees. 11 pi over 6 is 11 times 30 degrees. So I've got to decide, which angle do I use? I can't use both of them. Can I? No. Oh, what do I do? 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 I have to look at what is given to me here and how I graph this in the, let me grab this a second. In the where? In the real and the imaginary plane. So I should have this down here. Where did you just go? You see the word real anywhere? Okay, I'm gonna try that again. Where did you go? Oh, you went over here. Ah, you went over there. I don't want you there. I want you over here. So again, this is the real. And what else do I need? If you do this, you will never, and that's how I'm spelling imaginary today, okay. If you do this, you will never goof up your angle. So let's consider x is negative. If x is negative and y is up here at positive, I don't know exactly what the square root of 3 is, but it's between 1 and 2, so I'm going to go over here. Actually, I can get my calculator on. Go, what's the square root of 3? The square root of 3 is approximately 1.7. So I'm going in the, because there's a negative here, I'm going there's negative, and I'm going up on the y, on the imaginary axis to 1. And I'm saying that's a pretty good place for my vector to be. And then I can see the angle I'm supposed to use is not 330 degrees. The angle I'm supposed to use is that 100. See how that's almost looks like a 150 degree angle? Because I did my notes so well. Yeah, right. So do I have my answer yet? I'm working my way towards the answer. My answer has to be in r cis theta form, r cosine of my angle. But I figured out what r was. R was 2. So my answer in trig form is this. Two is my r. my angle here is 150 degrees, and you can write this down if you want, but I usually write it as 2 cis 150 degrees. This is just taking so much work. But the 2 stands for the length of your vector, the r, and the c stands for the cosine. The I stands for, I've got to have an I in front of the sine theta. I can write that. If you do not want to write it that way, you could write it also using radians. 5 pi over 6 is the same as 150 degrees. So my final answer is, well, it depends. Depends on what the book asked me to do. Do they want my angle in degrees, or do they want my angle in radians? Please make sure that you read the directions, because lots of times they will say they want it in 0 to 2 pi form, or 0 to 360 degrees would be, this is the answer. So both of these are the answer. I just have to see what the problem asked me in a particular question. I will say I want theta between 0 and 2 pi, or theta between 0 and 360 degrees. Now, I've been pretty lenient so far and giving you credit. You didn't follow those directions, and I can't do that anymore. I have to make sure that you're following the directions and you're reading my math. Okay? Woo! Let me save this. Do one more example, and then we'll take a break. Okay, we're now going to, oh, I think I have the circle here for a reason. I think I'm going to circle that. I don't know why exactly, but I can. Okay. Oh no, I want to circle this one. This is the angle that I want, all right? There's 2 possibilities from 0 to 2 pi. I mean, from 0 to 360, and I'm going to choose that one first. That's where that circle goes. Okay, let's look at 5 plus 5i in trig form. You ready to go? Okay, 5 minus 5i. What is it? Let me move this down. You're given x plus yi. We want our cis theta. So the x is, obviously, to me that looks pretty easy. The x is 5. The y is -5. Let me make sure I didn't goof up this negative sign, okay? So when I go to find, what am I going to try to find first? Well, we got to find r, so we might as well find r. X squared plus y squared equals r squared. 5 squared plus -5 squared. 25 plus 25, just 50. Taking the square root of 50, which is simplified into 25 times 2. R, that's my r. My r is 5 radical 2. This stuff is not going to take you very long at all, did you? Next thing I have to do is, well, I found my r. Now I have to find my angle theta so I can write my cis theta down. So how did I find it before? Oh, I did the tangent ratio. So I'm going to go ahead and do this tangent ratio. I hope I don't have to use a calculator, because I hope this one's in my mathematical tool. I'm going to use the tangent of theta is, the y is -5. I don't know why I don't have it filled in. Or maybe I did down here. Yes. The y is -5. That gives me the tangent being -1. Okay, now I got some issues. I know when the tangent is -1. The answer is, well, the answer is, it could be 135 degrees. It could also be 315 degrees. Tangent is negative in quadrant. Aren't you so glad you learned the unit circle? The tangent is negative in quadrant 2 and quadrant 4, and at a 45-degree reference angle, so 135 degrees. Which one do we use? I don't know. Let me go ahead and step number 1. Let me go ahead and graph this. X is 5. Let me grab this. X is 5. Grab my point. Come on, point. Let me grab you. X is 5. And what's my y? -5? Oh no, don't move the X and Y axis. Those aren't X axis. This is a real axis. Let me copy this. This is a real axis. First thing you need to do, and again, it's called proper notation and all that good stuff. That's the real axis, and this is the other one is the
Imaginary.
axis, also known as IMG right now. Okay. Oh, let me go ahead and spell imaginary. I am, just lost my train of thought. How do you spell imaginary? Imaginary, there you go. I've got X being 5. and I've got y being -5. What quadrant does that put me in? That puts me in quadrant 4. Oh, but that's not a very good graph, because since I am in the real and imaginary plane, what I really need to do is I need to make myself a vector, because that's the vector that has the length of 5 radical 2. Now, my angle, let me see if I can do this. My angle has to go all the way around here to quadrant. Come on, can you go further? There we go. My angle has to go all the way to quadrant. It's amazing some of the things I can do on Microsoft Word. My angle has to go into quadrant 4. So I know exactly which angle I have to have. So my final answer, here it is I'm going to put my R in the front. My R, which is 5 radical 2. I'm going to put my, what am I doing? Okay, I'm going to put my cosine of 350 degrees plus I sine 350 degrees in my parentheses. But again, I'd much rather just call that 2 cis 315 degrees. But I have to let you know that sometimes textbooks don't always use this. You know, your physics book might not use that. And so they're going to say cosine 350 degrees plus I sine 350 degrees. You can also go ahead and put your answer in radians. R being in front of 5 radical 2. Whoa, that's a big. And my angle as 7 pi over 4.
Why is it 2 cis? I thought that
I don't know why that's 2 cis. That should be. That's because
okay, that was confusing
I
me.
copied it from right here. That's why. So let me go ahead and change that. Okay. Yeah, I'm looking at that going, okay, nobody asked, so okay. Because sometimes what I do is I'm typing this up, I'll just copy it over here. But I really should make this. Let me go ahead off the screen and change this to 5. And I have to do that on the next step too. I just saw that. 5 square root of 2, right? Square root. Wait a minute, where's the square root key? Square root of 2. And again, I can't do this on Word, so I have to kind of like go out of Word and go into math type and go ahead and do that. And again, this should be the same thing. Let me save that so I don't lose it. So I'm going to exit Word for a moment. This is 5 radical 2. And again, you can see I just copied that 2 from this one and changed the angle. Not good. Kind of going fast for me. 5, I need a radical. That's okay. Last week in calculus, because I exited into this math type, I lost my notes 3 times that day. It was not a good day for calculus last Wednesday. Okay, so what do I have here? Is this empty? Okay, this is empty. And this real that I copied, you're not supposed to be here. You're supposed to be gone. Except I probably need you on the next page, so maybe I'll keep you down here. Okay, so anything really too difficult so far? If you can take x squared plus y squared and get r squared, if you can take y over x and figure out what your angle is and what quadrant you're in, we're good to go. All right, so it's 9:55. We're going to take a 10-minute break. I am going to stop sharing for a second. I'm going to turn the recording off.